Hello and welcome to another edition of WAVY Science Lab. I'm your host, meteorologist Jeremy Wheeler, and today we are going to be talking about good and bad hair days, compliments of humidity. We all have different opinions about humidity. There's some people like Andy Fox that love humidity, which I don't get. And then there's some folks that love nice, cool, crisp, dry air, which I think is a lot of people. And they tend to be more comfortable when it comes to drier air. So we're going to talk all about humidity. We're going to talk about the history of it. We're going to talk about how it affects people, how it behaves in the environment. And we're going to talk about some basic things like, how we can get rid of it or how we can make it better, make it more humid. That's right. We can control it. So, a bad hair day, a good hair day. I mean, it changes everything. It changes everything for some folks. So some people, they have a lot of humidity and all of a sudden it's frizzo. And then next thing you know, you get a dry day and it's a good hair day. Thank you, Aisha, for participating. We appreciate that. Thank you. She's a good sport. All right, so good and a bad hair day. So let's talk more about what it is first, and then we'll go into the basics and the history. So humidity, what is it? Well, basically, it's how dry or sticky the air feels. That's very simple. Humid day, it's sticky outside. A dry day, like in autumn, like in fall, you go out there and it's nice and dry. So the amount of moisture in the air, that's just basically the scientific name for it, amount of moisture in the air. And so that means that you've got all this moisture. You can have water vapor. You can have water droplets in there. But I think it's really the water vapor in the air that we're talking about. Because if you have droplets in the air, then you're saturated. So that's when you have, your fog, which we're going to talk about. So how do we measure it? The hygrometer. Why not a hydrometer? I don't know. Because you'd think with the base wording, maybe it's Greek, maybe it's Latin. I didn't look that up, but it is hygrometer with a G, so it kind of throws people a little bit. And so that's how we measure it. Measures humidity by expanding hair and paper. That's right, hair. That's why you have a bad hair day. You get frizz when you get all that moisture in the air. And hair actually expands, not just human hair, but also animal hair. And we'll talk a little bit about that, believe it or not, in a little bit. Paper, sometimes they have some paper that can expand and contract, and it's calibrated so that you can actually measure it and how that works. Electronic resistance. So this is an electronic thermometer, but also has a hygrometer in it, and it measures it through electronic resistance. We'll talk a little more about that as well. So the history of the hygrometer, going back in history, the 1400s, Leonardo da Vinci, one of the best geniuses in the world back in the day, created a lot of things, knew a lot of things, created a crude hygrometer, and so that was in the 1400s. So the 1783, Horace Benedict de Saussure used a human hair and, I guess realized that it behaved that way before that point and then decided to get scientific and study it and, measure it. You can measure it. You can measure, it expands and contracts depending on the amount of humidity in the air and a little bit of temperature as well. But I think humidity is kind of a bigger factor, so that's how it can get measured. 1810, John Frederick Daniel, he invented the dew point hygrometer, so that's condensation on a mirror. And condensation is when you get little tiny droplets to pop up. So, modern hygrometers, various types. So you've got metal, which is interesting because I've got one right here. I'm surprised that metal would expand or contract. It has to maybe have it may be a little porous or something. It's a certain type of metal, but this is a hygrometer on the bottom. And so it's got that little metal coil, so it expands and contracts. But the thing is, the other one contracts and expands due to the temperature. So I don't know how that's differentiated. But it's interesting. And it works. It does work. It's just maybe it doesn't work quite as well as the electronic ones. All right, so let's go back to the text here. And so, again, these are different types of hygrometers. electrical resistance, thermal, capacitive, optical. So that's right. They can actually use optics and kind of measure the amount of moisture in a certain specific instrument and measure the amount of humidity using the optics. More humid air, if it's saturated rather, then it's harder to see through it, right? You get fog, it's hard to see. So those are some different types of modern ones. Sling psychrometer, I don't have one with me. I thought about putting one out here, but basically what that is you've got two thermometers and one's got a little wet sock on it and the other one's just dry. And so you actually spin it around and you can measure the difference between dry air and humid air because that water will evaporate off the sock. You get it wet and so it'll evaporate off the sock and then you literally can tell the different temperature between the two. And so that works pretty good. I actually used today. I have used one once a long time ago. When I was a boy. So the sling psychrometer is actually pretty cool. And National Weather Service, they do use that as well. So we're going to go into the types of humidity here in just a little bit. Before we do that, though, I do want to talk about this hygrometer again. And so this is one of them. Let me put you in full here. And so this is one of them. This is the hygrometer, and so it tells you the relative humidity, which we're going to go into in a little bit, a difference between absolute humidity, relative humidity. But this tells you the relative humidity. It even says it right here, relative humidity. Hey, all right. Oh, wait. And we've got the other one. This one is very specific. This one has the exact numbers in there. That one, it's maybe not as accurate, but this one, it tells you that the relative humidity in here is 40%, which is quite, getting low. Now, outside, that's a whole different story. But these different instruments do that. And then, we've got ways to measure the humidity and, try and tell you if the humidity is going up or down or how dry it is inside and outside. You have instruments out there. They're at airports around the region. And so there's actual hygrometers at airports. So all the instruments that we use usually when I show you things like this, and I'll get a little ahead of it, but this is the relative humidity. So when I show this to you, these are at airports or military installations around the area. So that's how we get the information, and then that's how we give out the information. All right, so what we're going to do is we're going to take a break here, and then when we come back, we're going to talk a little more about those types of humidity and get very nerdy, very scientific here. All right? All right, we are back, and I do want to mention one thing. By the way, I showed Aisha off the top, Aisha Tolliver, and I asked her if it was okay to do the good hair day, bad hair day thing, and she said it was fine, and so she was a good sport. I will have another example of good and bad hair days towards the end of this presentation, but towards the very end. All right, so let's talk more about the types of humidity. And so we've got absolute humidity. That's the total amount of water vapor in the air, right? That's how much moisture is in the air, grams per cubic centimeter, I believe. And so you've also got relative humidity. So it's the amount of water vapor in the air compared to the maximum vapor that can exist. So, what does that mean? Well, some things can hold more water than others, and it really depends on the temperature as far as my world goes. So, when you raise the temperature, then you've got more capacity, right? You can hold more moisture, and we're familiar with that. The moisture down south, down in Florida, the humid air comes up, the hot humid air, and so it holds more moisture, and then if not, it gets squeezed out. So now let's take a look at the other types here. So, basically, this is a good explainer here. So this is relative humidity, representative amount of water vapor in the air. And so the first one, you can see there's 10%, moisture in that bubble. Second one is 50%, about half covered, and then 75%. So, that's the relative humidity, 50% relative humidity. Now, let's imagine that we heat up these bubbles. And so now we raise the temperature, and so what's going to happen is now your relative humidity has gone down. The amount of moisture is the same, but your capacity, the area, the size of the bubble basically has increased. And so now it's less humid relatively. It's, you know, a lower relative humidity. So now the middle one's 30%. The final one is 60%. So that just shows you kind of how it works, how relative humidity works. It's an interesting thing. Now let's go on to the next thing. And there we go. Pardon me. Have to change the title there. All right. So, oh, pardon me. Oh, getting used to these buttons. There we go. So now we're going to talk about, you know, different relative humidities around the area. So I mentioned that, you know, these are airports, and they are. And so these show you the relative humidity at different locations. So, you know, at the time that I recorded this, you know, 82% in Norfolk. Wow, that's a lot of humidity. So, you know, sometimes we get the wind off the water and it changes things, got a marine layer. Chesapeake was probably hotter at the time, so 64% relative humidity. So the dew point, this is the temperature at which saturation, condensation occurs. So you cool things down enough and that moisture gets squeezed out, and so now you start to get little liquid droplets to form. And I had a great example idea. I thought, all right, well, I'll get a cold mug. I put a bunch of ice in here. I thought, well, there'll be some condensation on the top of it. Well, the problem is there's a little bit there. I mean, it is moist, but this is an insulated mug, and the relative humidity here dropped because the lights warmed up. And so, you know, it's like the Incredibles, you know, when they're Frozone and Mr. Incredible in there, and he's like, I thought you could use the moisture in the air. There is no moisture in this air. What's your problem? You run out of muscle? So we run out of moisture in the air. There's not much in here. So that's why there's no droplets on my mug. So failure. Fog, air becomes saturated, liquid droplets form. Your temperatures cool down to the dew point at that point. And so let's have a look at some fog. This was at Norfolk International on a different day. And yes, so now what happened was, you know, we had a lot of moisture in the air. The temperature cooled probably in the overnight down to the dew point, and then, you know, the air became saturated. So now we got little teeny tiny particles floating around in the air. Little, you know, they're like cloud particles on the ground. And so this is a good example of that. That's fog at Norfolk International. And so that's one way you can get fog. Radiational cooling, meaning that you can cool things down at night. That heat escapes into space, and then you cool down the temperature to the dew point. So there you go with that. And let's take a look at this other one. This is a marine layer fog. So this is common out in California. It's courtesy of NOAA. And you can see the Golden Gate Bridge. So the water is cooler. And so the air, when it goes over that, sometimes it's much cooler. So it cools down the air to the dew point, and then you get that marine layer fog to form. Now, that does happen here. I don't have a good example of it. I wish I did, but that does happen here. And so, you know, that reduces your visibility, and you can't see, you know, boaters, and it affects airports, of course. You know, planes have to be able to see. They got different rules, flight rules for flying through low visibility, and then they can't take off if it's really bad visibility. But they do, you know, try and do their best. They do a great job, pilots. I have a lot of respect for them. And we used to have, you know, when I've gone up, rather, in the back in the day, Chopper 10, I've only gone up a few times. One time there was fog, and the pilot, he told me, you know, you got to be careful. You can't fly over it because you don't know if you'll be able to get back. So just to play it safe. So that was interesting. We were going into the Virginia Limb Museum for, I think, Groundhog Day. So that was a long time ago, though. Okay, so anyway, so you can get different types of fog. In this instance, at the time I recorded this, you know, the visibility was good, but a lot of times the visibility drops. And so it'll affect traffic, because then, of course, we know that when you're going in and all of a sudden your visibility drops down to almost nothing. Well, you have to slow down because the vehicle in front of you, and you don't want to use those high beam headlights. Use those low beam headlights when you've got fog. So that's another recommendation. All right, so that's visibility. Here's the dew points at the time. You know, dew point of 75. That's high. And we use this quite a bit to show people the humidity. And, you know, it's good because, but the problem is, you know, I could show folks the relative humidity, you know, I could show that. But the thing is, that changes throughout the day because the temperature changes. And so, you know, you've got in the morning, of course, the air is cooler and saturated, but in the afternoon, you heat things up, that relative humidity drops. But the dew points don't change that much during the day. The only way they really they change a little bit, They can change by the wind blowing in cooler, drier air. And sometimes you get some moisture in the air. Let's say it rained the night before and that evaporates. Well, sometimes that moisture that evaporates in the air gets on the sensors, on the actual hygrometer. So, it can offset it a little bit. But, I mean, we're trained to pick that out and know that. So the bottom line is, these dew points, a lot of times in the summer, those dew points are shooting up around 70, 75. You're sweating, and then you get into fall, and they start dropping to the 40s and 50s. Your temperature can't go below the dew point. So when you have the cooler, the drier air in here, you can get potentially cooler air as well. And so it's a big feedback. That's how it works. All right, we're going to come back in just a little bit, and we're going to talk a little more about how you can get it in and out of your home and how it affects us. All right, we're back. Oh, sorry, I popped in kind of on you. But yes, we are back, and we're talking now about, of course, humidity. But now we're going to talk about kind of every day and how it affects people a little bit. One thing I think I do need to go back to, though, and that is the atmosphere. So, humidity is highest at the surface. You go up in height. I know this is pressure, but the humidity also decreases with height. And that's just, we understand that pretty well. You go up way high, and of course, the moisture just doesn't get up there. You go up the mountains, and, it's much drier aloft. And so that just goes without saying. But that's why I want to go to the mountains and get out of this humidity today, I think, myself. Okay, so let's talk about some ways to try and affect ourselves and change our lives. And so we've got humidifiers, dehumidifiers, things like that. So a dehumidifier works as air is pulled into the unit, and then it's run over cooled coils, metal coils. And so then it cools down to the dew point. That dew point then creates the little tiny droplets of water. And, if it's cold enough, it can start happening quite a bit. And so that water then can get taken out and put somewhere else. So water condensed in the coils removed, and you use a refrigerant. The machines use a refrigerant for that, and works pretty good. Now let's take a look at not yet, but the dryer air is then pushed out, right? So I actually have an example of a dehumidifier. So this is it right here. This is a dehumidifier. It is a low-powered one, so that's how I can use it work. I think the watt is about the same as a light bulb, which is neat. It does work a little differently. I'm not exactly sure, but the premise is the same. And so this morning I ran it for a while, and then can't really show it to you, but I will show you that there is water in there. So there's about maybe it's more than a couple teaspoons, or tablespoons rather, but there is a little bit of water in here from the atmosphere, from the air. So that was this morning, and the AC units work pretty good, but sometimes it's so humid that I try and give it a little help locally in my little station. And so, plus it's an air filter, so it helps me out that way. So that's my personal example from the station. I have a higher powered dehumidifier, and that one is one I use at home. I work out in the garage, and so I use the dehumidifier out there when it's really humid. The thing is, that one works how I mentioned before, and so it does release heat from the process. So it pushes out drier air, but that drier air is warmer. And so it kind of, on a really hot, humid day, it kind of counteracts, and you can't exactly, you can use it, but you can only use it for a little while. So, some examples here, you can use a dehumidifier in your home. Maybe you've got a really humid location. So this is a wet shower stall. I had the shower running, and then, of course, that moisture, there's moisture in the air, but this adds to the moisture when you got a hot shower, and then that collects, and then moisture condenses inside of that shower. So what you want to do is you want to use that bath fan. The bath fan is very important. Lots of folks don't understand that you have to get that moisture out of your home because you can get mold to grow. Mold can grow at a relative humidity about 55% or higher generally, but 60% or higher, that's not good. And that happens quite a bit. When you get that shower out there, you're running it, you want to get that moisture out of there because it will, I got to clean that vent. Oh yeah, boy. All right, so Yeah, but you want to get that moisture out. So run that bath fan, get it out of there. I'm on my family usually. I was like, hey, run the bath fan, get it out. And you leave the shower door open so that the dry air gets in there a little bit. Maybe not all the way open, but at least a little bit. And so that is some advice for that. And now I mentioned, ways to get rid of moisture, but there's also sometimes, when you're in the wintertime, it's really cold outside, and so your capacity to hold that moisture decreases. And so when that air comes into your house and you heat it up, you're really decreasing that relative humidity. And one time up in Illinois, when it was, I think, minus 18 or something, I had a way to measure the humidity in the home, and it was about 6%. I mean, deserts are, about that. And so it was amazing, bone dry. So what we did was, you've got the humidifier, also known as a vaporizer. Boy. It's called a vaporizer. And so a lot of people use this when the kids are sick because it's so dry at home, in their home, during the wintertime especially, that they want to add some moisture. It's more comfortable for breathing, right? You don't want your nasal passages to dry out. So that is a way that you can actually add some moisture and, try and make it a little more comfortable in your home. So you've got dehumidifiers, you've got vaporizers, and so you can actually control that humidity in your home. But again, in the summertime especially, you want to try and run that bath fan, or at least try and dry out, your home as much as possible. Crawl spaces, that's a big issue. They try and keep the relative humidity down in those as well. So that is a issue sometimes, because then you got mold growing in the crawl space. And so now a lot of times they'll just seal them up, and they've got special ways to try and dry those out. All right, so let's take a look at one thing here. I'm a little hesitant to do it, but I think I must. All right. Wow. That is a bad hair day right there. So I'm volunteering myself. So that was a very humid day, of course, and then you got the good hair day to go. So yeah. All right. So we talked about humidity. Being, bad if it's really high, bad if it's really dry. So you got to try and balance it out in your home. And we'll talk a little more about that in another podcast about cooling down the home and things like that. So we'll finish today on the environmental tip of the day. You're washing your clothes, use less hot water. That's right. Using cool or cold water uses about 1/10 of the energy as hot water. So there's so many settings out there now. I mean, cool, cold. This is mine anyway. Mild, warm, hot. A lot of people use hot. I try and take it down a notch below where I probably should use it. So that is some environmental tip to try and save on energy. You can save on energy in your home. Well, thank you very much for joining us today. It was a lot of fun. And we'll be back with more episodes, and you'll hopefully learn some more things. So everybody, thanks for joining us today, and I hope you have a good one.